All right, let's dive into something pretty cool today, the spiral model. It's this really powerful, risk-driven way of building complex stuff. And honestly, it's been the secret weapon behind some of the most ambitious engineering projects out there. So let's get right into it.
So, think about this for a second. How do you build something that's truly groundbreaking when you literally can't predict the future? You don't know all the problems you're going to face from the get-go? Well, that is the exact puzzle the spiral model was created to solve. It's made for a world filled with uncertainty and constant change.
Okay, so to really get why the spiral model is so smart, we first have to talk about the big problem it was trying to fix, the challenge of uncertainty. We got to look at why the old ways of doing things just weren't cutting it anymore.
So here's the core of the issue. You've got these older, more linear models. Think of the Waterfall Model. They treat building software kind of like building a bridge, right? You have to have the entire blueprint perfect before you lay a single stone. But what if you're not building a bridge? What if you're exploring a brand new continent? The map is literally being drawn as you explore. That's where that rigid, plan everything up front idea just completely falls apart.
And so, faced with this messy, unpredictable reality, the world needed a new playbook. And that's where the spiral model comes in. It was built from the ground up to thrive in exactly that kind of chaos.
Now, the real genius here is that the spiral model isn't some brand new thing pulled out of thin air. Nope, it's actually a super clever hybrid. Think of it this way. It takes the whole let's build a quick version, learn from it, and iterate idea from prototyping, and it smashes it together with the serious, step-by-step discipline of something like the waterfall model. So you get this amazing mix of flexibility and control. The best of both worlds, really.
And get this isn't some hot new trend from last week. This model was actually developed by a guy named Barry Boehm way back in the 1980s. So why are we still talking about it? Because its core idea is timeless. It's all about managing risk. And when you're talking about things like aerospace or mission-critical medical software, places where failure is not an option, that focus on risk isn't just a nice-to-have. It is everything.
Okay, so that all sounds great, but how does it actually work? Let's get into the nuts and bolts and break down the anatomy of a single spiral.
Basically, every single loop or spiral goes through 4 main stages. And it all kicks off with step 1, planning. This is where the team gets together and figures out, okay, what are we trying to accomplish in this specific cycle? What are our goals? Then comes step 2, and you really got to pay attention here, because this is the heart of the whole thing, risk analysis. This is where the team proactively asks, what's the biggest thing that could derail this project right now? And they don't just talk about it, they might build a small prototype or run a simulation specifically to tackle that one big risk. All right. Only after they've analyzed that risk do they move on to step 3, engineering. This is where the actual coding and building happens. They develop and test that piece of the system, but here's the key. It's all guided by what they just learned in the risk analysis phase. And finally, we hit step 4, evaluation. The client or the stakeholders, they take a look at what was just built. They give their feedback, and that feedback becomes the starting point for the planning phase of the next spiral. So you see, it's this continuous refining loop. Plan, analyze, build, and review, over and over again.
So, look, if you remember just one thing from all this, let it be this. The spiral model is, at its core, risk-driven development. The guiding question isn't, what's the coolest feature we can add next? No, it's what is the single biggest risk that could kill this project? And whatever the answer is, that's what they tackle in the next loop. Period.
Now, this all sounds pretty amazing, right? But hey, no model is perfect. It's not a silver bullet for every single problem. So let's be honest and weigh the pros and the cons here. On the plus side, you've got incredible flexibility and just top-notch risk management. That's huge. But there's always a but, right? All that good stuff comes at a cost. All that constant analysis and prototyping and reviewing, well, it can get really complex and honestly pretty expensive. This isn't something you can just jump into. It takes a ton of expertise and management overhead to pull it off correctly.
Okay, so given those trade-offs, you're probably wondering, when would anyone actually use this thing today? Where does the spiral model really fit in the modern world?
Well, this model really truly shines when the stakes are astronomically high. We're talking about huge, complex, mission-critical projects. Think about it, building the software for a Mars rover, or developing a brand new, never-before-seen AI system where you don't even know what it's capable of yet. In those cases, that intense focus on killing risks one by one, it's not just a good idea, it's absolutely essential for the project to even survive.
And that kind of brings us to a really interesting final thought. I mean, today, the tech world is obsessed with being agile, right? It's all about moving fast, being flexible, shipping quickly. So it makes you wonder, in a world that prizes speed above all else, is there still a place for the spiral model's slow, deliberate, superstructured approach to risk? Does it still hold the key to building our biggest, most important, most ambitious projects? I'll leave you with that one to think about.